Tonight we're gonna learn the fundamentals of RFI, and I'll tell you what. If you're in a metal shack, I bought an actual shack. It's an actual 14 by 10 tool shed, and I insulated it and drywalled it and painted it and ran electricity and did all the normal things. The only thing I didn't put in that I wish I did was a urinal. But anyway, it works really well, and I love my shack, but it's got metal on the outside, and this thing is a Faraday cage in here. And I have all kinds of issues with RF inside the shack, and that's kind of what brought me into this topic tonight, was the issues I've been having, and I wanted to get you guys to help me out fix my issues in the shack, okay? So we're gonna talk about ferrite filters and how to use and buy the right ferrite filter. This is one of those ham radio topics where you can get into the math and you can go in and actually figure out exactly which ferrite you need, how many you need, this and that and the other thing. We're not going into the math tonight. I would need to find someone to get into that. That's just too deep. If someone here would like to go as deep as they can, that's fine. I trust you guys to give us what information you can impart on us. We're going to talk about how to use ferrites to solve the #1 RFI problem shared by all hams using coax-fed HF antennas. And that's basically just the errant transmission running back up the line. We all know what happens, and these little jewels fix that. You guys already know we put a bunch of these out at the end of the antenna. I know on the hex beam, I think there's 8 of these on the hex beam. What do they call it? There's a name for it. But anyway,
a choke balance.
A choke balance, and there's 8 of these. I think 8 or 10 of these on there, and it works good on that end. But I don't have any on this end, so I think I'm going to put a few on this end too. But I've got all kinds of lines. I've got, I think, 12 antennas out there. 3 of them are HF. Yeah, so I'm getting a lot of RF in here, and it's getting a little bit of crazy. So we're going to talk about all that kind of stuff, and we're going to try to understand the concepts a little with no math. I really don't want. I can't get into the math tonight. The net tonight is for contesters, DXers, rag chewers. You know, anybody that's a ham could use to lower the noise floor and lower the amount of errant RF in your shack. So that's what we're going to be talking about tonight. So again, I ask you guys to participate because I don't have all the answers to this, and I need you guys to help me with it. All right, let's see here. The next thing, it can affect every aspect of the hobby. Not only is it a high noise floor, you can have high noise floor issues. You could have something outside the shack that's providing a specific amount of interference on a certain frequency. That's something different, and we can deal with that. You may also be having problems with your neighbors reporting that they're having issues. And you know what? It might be worth $5 worth of ferrite traps to get them to stop listening, if you know what I mean. Just go over to their house and say, look, I'm going to put these on the back of your TV, and it'll quit. I will tell you something. New technology, and I read something today. You know, the FCC is not really even dealing with, like if your neighbor calls the FCC because of your ham radio, they're not even really dealing with that anymore. Because the FCC now says, #1, they don't have enough people to deal with it. That's always the case. But #2, they're not dealing with it because all this new technology, my new camera system, the newer TVs that I've bought, all my newer stuff, even my new smartphones, they're unaffected by RF. I don't have any problems. It's always my older mouses, my older peripherals, my older computers, the older screens that I have. They're the ones having the problem. And what the FCC is saying right now, and what I read, was that because of all the emergence of new technology that is not affected by low-band RF, they're literally just getting out of the business of policing it as far as your neighbors calling and things like that. But to save yourself some time and trouble, if your neighbor comes over and says, hey, you know, I think sometimes when you're talking on the radio, my TV goes a little crazy. offer $3 worth of ferrite traps and go stick them on the back of his TV. It might just solve the problem and he can have them. But that's the other thing. And then we talk about noise floor. We talked about your neighbors. And of course, the third kind that's really a problem is the RF being trapped inside the shack. That's the one that's affecting me the most. I haven't had any complaints from my neighbors. Now that I went to my digital camera system, it's no longer affected by HF at all. So I haven't had those problems. I got a high noise floor on 40, and I'm hoping to work on that too. But other than that, I don't have those first two problems that bad. My problem is all this shack RF in here. So I'm going to be putting 50 ferrite traps along with the 25 I already have. And I'm ferrite trapping everything. And I'm going to see if I can get this to quit doing this. On certain, like my signal link box right here, okay? I have to be very careful how I run these wires. They have to be run directly away from the feed lines for the radio, or if I go over 50 watts on certain bands, the signal link drops out and it drops the transmitter, and that's it. I'm done. My QSO's over, and they have to wait for the cycle to go again. So basically, the best thing to do is, again, ferrite traps. Now, I'm going to open this up. Is there someone who has dealt with this that would like to talk on it?
I can give you a few pointers.
Please do.
All right, number one, you've got to change the way you're thinking.
Okay.
Because you just said that you've got 8 antennas. Well, that's wrong. You've got one antenna with 8 access points.
Yeah, okay. I mean, yeah.
Okay. So so change your mind of thinking on that. RFI and noise floor are two completely different things. If you eliminate RFI, you're not going to eliminate your noise floor problem. That's something different. It can be, your noise floor can be RF generated by something else, but you're looking to eliminate RFI generated by your own HF, as far as I can tell at the moment. And the other thing is, did you ground your shack? And have you got, 8-foot grounding poles, rods, 2 or 3 of them around your shack or something like that, and then grounded your shack, and then ground everything to that single point and ground your antennas coming into the shack at that point?
Yes.
That's probably the most important thing I can think of for getting.
Yeah, me too.
It is. And I have got my shack, the shell of my shack, as well as all of my rigs that have grounds on them, and my tuner are all grounded, but they're grounded to FP&L's ground rod. I have a ground rod, but I don't have it in the ground yet. So I'm getting there.
Okay, yes. So you want to, if you want, so really I would put 3, you said 10 by 14 or something?
Yeah.
I would put at least 3 ground rods around your shack. Put one really close to where you're bringing in all the antennas.
Right.
And I would then ground those to, if they're no more than 15 feet away, ground them to the electrical ground for your house. You see, there's a subtle difference here. It's between, if your shack is really close to the house, then it counts as the house. But if it's separate from the house, as far as code goes, if you've got your shack inside your house and you put grounds in for your antennas in your house, that ground must be grounded to the electricity ground, your electrical company's ground. Yeah, the supplier's ground. But if your shack is, separate from the house, and it's kind of undefined, I don't know what separate means, 10 feet, 20 feet, 15 feet, I don't know. But if it's a little way away from your house, then you don't have to ground it to, in your case, I think you said FP&L or whatever it is. So I would do those before you do any ferrite traps or ferrite beads or something like that, because that's probably going to eliminate most of your problems. And the word elimination, as far as RFI is concerned, doesn't exist unless you've got, your coax are perfect length, your antennas are a perfect 50 ohms, 75 ohms, 300 ohms, 200 ohms, whatever you're working at for your feed line, you're not going to eliminate it. You're just going to eliminate it from that particular device, but it's still going to, there's no way of, if you've got it inside your shack, there really is no way of eliminating it from inside your shack. You can eliminate it from getting into the equipment in your shack, but you say your shack's a Faraday cage, so in theory it shouldn't be getting in through a Faraday cage.
Yeah.
No, I don't think it's not that it's getting in. I think it's leaking from within here, and it's in here with me.
So you're generating it internally, you think?
I think so, probably because maybe the coax isn't the best or whatever. But I have my most issues with the way the wires are all behind the radio. Like I said, right now, all my USB peripherals have to be routed directly away from all of my feed lines coming in, because those two together seem to be a real problem. Which is,
well, that makes sense, because you know what's a piece of wire?
An
antenna.
Yeah.
So any piece of wire you've got out there is an antenna, and it's gonna receive signals. So if you haven't got a perfectly balanced antenna system, and you've got signal coming back down the screen of your coax, there's nothing to stop that getting into other cables. And you're going to get it into the cable. You can trap it, but it's still going to be into the cable. So, yeah, I mean, if I would work on the ground first of all, that would be most important, and make sure that all your antennas are grounded at the point in which they enter your shack, and that probably will eliminate 90% of your problems.
Yep, common point, ground plane. That's real important.
Really important.
That's what everybody's telling me too. You got to have like one of the setups I saw that looked like it was really good was they put a metal box in the wall, and they had a conduit going through the wall, or multiple conduits actually. And that box was metal. And then they had his lightning surge protectors, but that was also grounding the coax, the shield of the coax. All that was connected together at one place, and then there was a ground rod right outside it. I think there was.
What I've got going here.
Yeah.
So it was all like right there. There's one box. Everything came in through one location. It was all grounded together. And that would probably help with some interference too, because you have everything at a single point. You don't have stuff crossing over each other and feeding into each other and stuff like that.
This is
grounding and bonding.
Yeah.
There you go.
This is a really good read. You know, it goes from very simple to extremely complicated, but it gives you an insight. But just don't think of, you've got, you know, so if you've got a couple of HF antennas and they're going to two different radios, as soon as, you know, you've got to assume that's the same antenna with just two entrance points. And if you do that and you get your head wrapped around that, you know, you can kind of approach the idea of eliminating RFI with a better, at least I did anyway, with a better approach to it. I mean, my problem here, which is, you know, different than most, I know my antennas are all in the attic, although I have got 15-foot ceilings, the antennas are not an awful way up. That's it, that's perfect.
Yep.
That's the way.
There you go.
You see that whole copper shield at the back, the back of that box, all of it is copper.
Yep.
Right.
It's all grounded together.
All ground together.
And what are
Those
these?
may or may not be lightning surge protectors.
I was
Those
just gonna
lightning
say,
things
these
too.
are polyphasers, I think.
Yeah, they're polysavers, they're lightning. And if
Yeah.
you look in the bottom right-hand corner, coming out of the box, that is the, you know, that weave there, that is going to the grounding rod, and that rod will be 8 foot long and pounded right into the ground. There'd be 2 or 3 inches above it. And then the ground coming from the stem in the top left-hand corner, you've got more, that's going into the shack, and there will be a bus bar in the shack that is a grounding rod. And it doesn't have to be complicated. Let me just show you if I can do this.
Yeah, my problem's not the complication or the work that's involved, it's the money that's involved. This stuff's expensive.
It is. Yeah. Like,
Yeah, but you don't have to go to those extremes.
No, I know this is pretty. It doesn't have to be pretty.
No, I mean, if I could, I think I can log on. If I log on with my phone and I can use my phone, I can show you what I've done, and it is really, and it was really effective. But basically, I went to Home Depot, and if you go to the electrical department where you've got all the electrical boxes, the breaker boxes and stuff, they sell a strip of with screws in the top, you know, like a grounding rod.
Yeah, the grounding
that you
block.
put,
Yeah.
that you put, not a rod, it's a distribution block.
Mhm.
And that's all I use. And I use, you know, this grounding. I use this stuff, if you can see it, just regular green 14 gauge from Home Depot,
12 gauge wire.
and take it from every single unit that I've got and put it into thing. If I got Zoom on here, I can show you a picture of mine. It really isn't expensive.
Now, what's the advantage of using that like grounding strap stuff instead of just like big electrical wire? Is there any advantage to using that?
Some people say there is, and some people say there isn't. If you've got, don't forget, we're dealing with, as soon as you get any piece of wire a quarter wave away from the ground, effectively it's open circuit. So, you know, it's an antenna again. It's a quarter wave, vertical, horizontal, whatever. So by doing that, the weave, some people say it eliminates some of the, you know, I'm trying to get my lighting back, yeah. It eliminates some of the cross, you know, the antenna not being ground, if you like, the wire becoming an antenna.
Okay.
A quarter wave across. Yeah, these polyphrases, I don't know. You know, I've never used them. I mean, they seem to be an awful lot of money to me. And these little bronze transition clamps, you can. I've got one here. Look, you can get these.
You can get those at the Home Depot.
Yeah, look, this is. I don't know if you can see this. Oh no, someone's sharing the screens, but
That looks like an 8.
I'll show you what I bought. I bought these. I don't know if you can see it. Oh, I've got to put it in front of me.
Yeah, those are the 8.
And then it's got the screw in the bottom. This screws in and out. And this goes over the pole. And then you put your wire in there. I haven't got great lighting in here, but
It
I
goes
know.
over the grounding rod.
Yeah, and these things are, I don't know, they're really not expensive. Can't remember how much they are. I buy these at like you'll get these.
Home Depot has them.
Yeah, but you can get these used. It doesn't matter if they're used; they're just going outside on the pole from the, you know, the Saturday Hamfest thing that we have.
Yeah, they may have those.
The swap shop.
Yeah.
I bought a few at the swap shop. I think I bought 5 for $5.
Poly
They're all
phrases?
different sizes.
Oh, those things. Yeah. Okay. Yeah, I've seen those there. Yeah,
Yeah.
they got that kind of stuff. My concern when I went looking for all this stuff a while back, because I wanted to do this before lightning season this year, and and I can't afford it. I mean, these things are expensive. Now, you guys tell me, when you look at this right here, is this an option for me? I mean, this looks pretty cheap.
Lightning arrestor and female to male. Well, this is an N connector, but
Well, yeah, I mean, I don't want to use adapters, but I can probably get it with the right connectors.
oh
Yeah,
look,
there's
that's
one.
N
There-
to.
SUH, yeah, okay.
That's the right one, and it's a surface mount.
I don't think they are. I think they're in line. I don't think you mount them to anything. So
Well,
basically, you
it
here.
it says bulkhead. That usually.
Yeah, but that
and there's
goes through the bulkhead there, so you'd have to put
Right.
it through.
Yeah, you gotta have
Yeah.
to have something you can drill 5/8" hole in to support that.
Yeah,
That's pretty much. It looks like the same thing. It would do the same thing as a polyphaser. It's just in a different form. However, this brand or whatever, it's it's a lot cheaper than a polyphaser. I don't know if they're using cheaper, whatever.
I have no idea.
So it looks like it has reviews, but the only real way to test it is to have somebody get struck by lightning and then write a review. So
and the thing is that lightning is going to go through most stuff anyway. So I don't know. I don't use those, but most of my stuff is inside. But again, this is only going to be as good as the grounding you got.
Right.
So
well,
until you put the grounding right into your shack, these things are going to be useless. Because that center connection up there has got to go to a good ground.
Right.
You know, if you just put it in line with your coax,
it won't do anything.
It won't do anything.
Right, because there's nowhere. It has to provide a route.
Yeah.
And really, you need to get. I think you'll be pleasantly surprised if you put a decent ground into your shack. You put that. If you've got the post, you know, hammer it into the ground, put a good connection to it, ground the shack, ground your, you know, make something that grounds all your coaxes together. It doesn't really matter what it can do. I mean, you can buy a box full of. I bought some crimps off of eBay, no, off of Amazon, and it wasn't expensive, and I bought like 200 of them that go onto that clip onto the bottom of a regular 239 socket, SO 239 socket. I'm trying to look. Where's my Amazon?
This is what I've got here.
Yeah, that's that a bolt-on one? I've seen those. Yeah, those are quite good.
This is called the bulkhead. It's just like that one. And it attaches to the I've got a bracket out there with 10 5/8" holes. Well, heck, I've got another one, which is smaller, which I can show you. I'll go get it. To give you an idea what they look like. I got mine from Georgia Copper, so I'll show it to you. I'll go get it.
Well, and while he's getting that, I'll tell you, I wanted to do all this. I priced all this out. Now, I didn't see these cheaper polyphase. They're not polyphasers. These gas lightning arresters. I would be happy with those because I can't afford a $120 polyphaser for every antenna. And I really only need 6 antennas, 7 antennas up all the time anyway. I could probably bring that. But see, I've got 3 antennas that come into my 3 scanners, my 3 radios for the Broadcastify feed. Then I got 3 HF antennas. I got 6 meter, 10 through 20, and 40 and 80. So I got 3 different antennas there. And then I got 2 Ringos for 2 meter, 440. And then I got another 2 meter directional. Man, I got a lot of antennas. And then I got the one we just put on his box in here. So
just because you disconnect one of those, that doesn't mean that it's not going to receive the signal that you're sending out on one of the others and bring it back into your shack that way.
Right.
So that's what I'm saying. You've really got one antenna with sounds like 9 or 10 different connections. As far as RF's concerned, it's you know, a small nightmare.
Yeah, and I'm not on a big lot. All my antennas are within 100 feet of each other. I mean,
yeah, but then and in addition to that,
as I can get.
Yeah, and in addition to that, you've got down spikes, you've got gutters, you've probably got metal doors, you've probably got a metal fence somewhere, you've got vehicles, you know, you've got a garage door, which is probably aluminum. You know, you've got a ton of stuff, and they're all antennas effectively. So, you know, you've got to look at it all and say, oh, that's one antenna, and I've just got all these different connections on it at different wavelengths to match it to the transmitter and the frequency I'm using. And if you look at it that way, then that'll help with you. You know, just don't put the coax, don't put a trap or a Balaam trap or whatever on one device. What I will show you, though, this is what I've done with my headphones, with quite a little bit of playing around.
Yep.
And that eliminated it from my headphones from, this was for HF, this is for 6 meters. So the HF one, if these are the cheap Amazon ones, they're about $9 for 10. I think it's $20 for 20 or something, all different sizes. All the other thing is that all ferrite beads are not equal. So this one goes up to 60 or 70 megs. This one only goes up to 30. So, you know, read the spec.
Right.
You have to dig a little bit deep on Amazon if you bought them from Amazon, but they're good. You know, they come in a little box like this. I don't know if I can't see myself, so I can't. I'm still working away on 6 meters. I got a ton of contacts tonight, but yeah, I've just got these few left. You know, they just clamp on. I bought 3 boxes, and then I'll give you an example. See if I can find myself on here. Yeah.
And while you're doing that, let me just say, guys, bear with us. We're going to be helping Dave, another different Dave. We're going to be helping him get his FT8 going here in just a minute, so don't go anywhere. Oh, look at that.
When things get serious.
Great.
Wow.
And actually this, you can test this on your Nano VNA or on your SWR meter and whatever, just by putting a dummy load on it. This goes up to just about 60 megs. And it's, if I can put it somewhere you can see it, there you go. So this is my kind of main feed on the switches. So this is my first elimination into the shack, if you like. So this doesn't go onto any rig. This goes before, because I've got one of those Ameritron switches up in the attic, and this is the feed from that. Rick was showing us something briefly. I saw it, which looked perfect. I don't know where he is. So you don't need to, I mean, I can't stress enough how much you need to, Rick, what were you showing us just now? Oh yeah, there we go.
Okay, this is the thing that this came from a company up in Georgia called Georgia Copper. They're up in Cleveland, Georgia. Now this is the what I call the 6-holer. I've got a 10-holer outside. All right, you can see these SO239 feed throughs, and this is what I used over at the apartment next door. I put a bigger one in here so I had more room, and I may wind up putting this one back out there too as I keep growing up and getting enough room. But you can put arresters in here too, such as this. It will fit it. This is an Alpha Delta unit, but I went with, you do a lot, but you do fine for yourself if you just do this. You put these feed throughs in this thing, and you run all, the idea of this is you run all your cables that are going into the shack through this thing. And this is all grounded together. So you get this is what we mean by common point ground plane. Everything goes through this, All of your shields are grounded together, and they go to the ground, which of course, like you were describing a while ago, several ground rods all tied to the utility ground. If you have a telephone line, you tie that in. If you got a cable TV line, you tie that in. All that stuff has to be tied together in the bonding ground. So,
okay, and one quick question now. Would I also run a large gauge piece of wire in from that panel there to come into the back of my radios and my tuner?
Yes.
Yeah, you can. I don't know that that's necessary. I don't leave my radios connected during storms. In fact, the rule I use here is when I'm not using the rig, it's disconnected from the antenna.
Yeah, but
from mid-May on through October.
Yeah, but the thing is, Rick, is that if you don't take a ground from that in, you're grounding all your radios through the coax. So all the radios are getting grounded, but sometimes
the coax hooked up. See, I've got another thing. Let me show you the other thingy I've got set up here.
Yeah, well, this is in answer to Ian's question. Yes, I think you should bring another grounding wire into your shack and have a grounding post in your shack, because a lot of radios sometimes the ground on the coax is not actually ground of the rig.
Yeah.
Sometimes it is, sometimes it isn't. But certainly with tuners it is, but not with a lot of rigs. But then there's all the other stuff you need to ground, like power supplies, like microphone amplifiers, like mixers, like I've got here, like amplifiers for your speakers,
Yeah.
like the switches. There's a bunch of stuff. But you really want, like
Let me
Rick
show
says,
you what
common
I've
point.
got here. I'm going to give you a little tour. I've got jalousie windows here. So what I did was I replaced one of those glass jalousie windows with this aluminum plate. And what that does, let me see if I can get this camera to where you can see that. It's all the wiring is all, and of course we're going to have to knock a half a dozen things over to get it where we can move it. All right, let's see if we can get the camera over there. And turn on some lights so we can see what the heck is going on here. Do y'all see that?
Wow.
Okay. You can see that this replaces a 30-some-foot-inch jalousie window. And can you see it at all? I can't tell what's going on.
Go down just a little bit.
Go down.
Yeah, well, you need to go down because all.
That's
yeah,
it.
There
That's
we
it.
go. There we
Perfect.
go.
Okay.
Oh wow.
So you got
Yeah,
end
that's cool.
connectors and SO239s.
Yeah. So you see two end connectors. One of them's covered with an adapter. Okay. On the end over there is a wing nut. That wing nut is for just exactly what we were talking about, is to feed a ground through. And I've got the other side of that grounded. So I've actually got two common point ground plates because that's grounded to the other one. So there's a number 6 piece of wire which is used to connect that to the other panel outside. What have I knocked down now? I got too much clutter here. But anyway, and Ian, if you come over, I'll show this to you, and you get to see it and get to see it live instead of on this on the screen here. But that'll give you an idea. I've actually got a double system here, and then that wing nut I'm going to tie into and run in here, and we'll get everything grounded up for that. Of course, that's the ground that goes outside to the all of the tied into the utility line and everything. So it's this is a work in progress. It's still going on. I wanted to get this because I don't have a way to show you the other one. So this is the old one, but I may wind up using it too.
All right. Let's go around again. Is there anybody else that has anything else on grounding that they'd like to impart with us?
Well, I gotta say, this is all very, very nice to have this discussion because I'm in the process right now of properly grounding everything, getting everything set up, because up until before I never really had anything that was that high up and really was that big of a concern. But now I'm starting to get into the more taller tower, you know, with the GP9 on top. It's like it's about is it 50 feet? I believe it's about 50 feet tall now total. So the lightning is a concern, and static, and just all kind of things I'm starting to try and get a proper setup going here. So it's been very nice having this discussion.
It's almost as bad as it is here in Florida.
Lightning?
Yeah.
Well, that's the thing. I've been trying to figure out, right? So the push-up pole is 30 feet tall when it's fully extended. It's 30 feet. And then on top of that, it goes up another 20 feet or 18 and a half feet with the GP9. My thing I've been trying to decide the last couple of days is, if I see a storm coming that may potentially have lightning, is it worth it to lower the antenna down by 20 feet if it's still a total height of 30 feet? Now, before, when I had the GP1, it made more sense because the total height of the antenna was reduced to about 16 feet. Now with the GP9, it's the same height as the tower was before when it was raised up. Now when it's lowered, it's the same height as when it was raised up before. So it's kind of like, well, why bother even going out there and struggling with this push-up pole while standing on a ladder if it's not going to make any difference? And I've been trying to figure out if your chances of getting struck by lightning go up at all with a difference of 20 feet. I've had people say no, I've had people say yes, and then some people didn't quite understand the question. So like if I have proper lightning protection, the tower is grounded, feed line is grounded with surge protectors, all that stuff done correctly the way you're supposed to do it, is it even worth it anymore to actually go out there and stand on the ladder and lower the tower down and deal with the tangled cables and everything? Does your chances of getting struck actually change with height?
If you hear a weather forecast and you want to do that, you better do it a few hours ahead of time.
Yeah, that's and the thing is, the other thing you got to ask yourself is, I mean, do you disconnect all your radios?
Yes.
You disconnect all your radios. So,
yeah, I do
and do you disconnect the, antenna inputs to the house, at the house, or inside somewhere?
Well, currently I don't have a disconnect at the house, so I just disconnect it and it runs along the concrete floor.
Yeah. Okay.
So the question is, the question is, I'm already doing the standard procedure for lightning. The question is that I'm trying to get answer to is, does 20 feet make that much of a difference in terms of likelihood of getting struck when your tower is 30 foot tall at its lowest?
To a lightning bolt, 30 feet doesn't make any difference at all.
Oh.
That's what I would think.
But the thing is, it's like when you're sat on the toilet, would you feel a little more confident with it down 20 feet or with it further up? It's how you feel about it. It's not what other people say.
Right. At this point, I don't really feel any safer with it down. I mean, I have a slightly more peace of mind. I'm like, all right, it's down. But then I realize, well, it's technically down, but that was up before. So
yeah, that lightning has probably just traveled, 3, 4, 5 miles. Is 20 feet going to make any difference?
That's what I mean. Like, is 20 feet?
Yeah, that's right.
Yeah. Is 20 feet going to make the lightning say, oh, well, it's too low, I can't strike that? I know lightning physics are all very, very complicated.
Yeah, the other thing is lightning is electricity. It's going to take the path of least resistance.
Right.
So is there anything around you, like here, we've got quite a lot of those huge radio towers and, cell phone towers and stuff. So if you're lower than all those and they're all relatively close to you, and I'm surrounded by water, and the amount of times it's hit the lake here, I'll tell you, see lightning strike a lake is stunning. It actually runs along the surface of the lake and makes the water boil.
Wow.
I mean, I wish I could take a picture of it. I would love to put like a camera system up like Ian's got, because we haven't got anybody who would catch fire to any house, but, lightning would be impressive to see. I've actually seen it twice. And it makes the water boil. There are videos on YouTube that people have taken when it's hitting a stream or something like that. So it's going to hit the point of least resistance. If you are the highest point around, then
I am the highest point in a radius of about 1,000 feet.
Whoa. Okay.
So when that thing is up, it sticks up above all the houses in the neighborhood. There's trees. That may not be accurate. We actually have some trees that are probably about the same height, but there's like a big open field next to us, and then we have a church that's about 1,000 feet away that I believe I've seen it get struck once before.
They are equipped with lightning rods.
Yeah.
So if I'm the highest thing in a radius of 1,000 feet, is that because everything else, it's like the land, we're kind of in a very slight valley. It's not a super big valley, but when you drive away from the house, you kind of realize that, yeah, it's actually not that high. But yeah, I'd say at about 1,000 feet radius, the closest thing that's of a comparable height is either the trees, which are about 300 feet away, or the church, which is 1,000 feet away.
And how far above sea level are you?
I don't know that actually.
I'm sure
I would imagine that's something I need to actually figure out here. I think I can use a compass here.
You should be able to tell that from your phone.
Yeah, that's what I'm doing here. I'm going to
If
check.
you've got an iPhone,
730 feet is what it says.
Okay, so and there is nothing around you that you've got hills or mountains that are higher.
Well, I mean, not like super close to us, but if I let me
There
me
are
break out
mountains around Huntsville.
let me take another measurement here, and I can tell you. So we have a mountain that's 2.5 miles away, and has a lot of towers on it.
That probably so.
Yeah, that's difficult. I mean, I always personally play on the side of caution, but
Right.
you know, that's because I'm older. You know,
I mean, like
I
if
don't
if
know
I
whether
know
20 feet make a difference, but
that's what I'm not sure. I mean, when it's down, the tip of the antenna is still taller than all the houses.
yeah, and there's no way you can.
Back, guys. I got to step out for a second. I'll be right back.
Okay.
There's no way that you can, you know, put one of those floating mechanisms or something on it.
It's a push-up pole, so I can't. The way it's mounted too, it has a really solid mount. That antenna as well. It says it has built-in lightning protection in the manual. So apparently that energy, and there's actually a video of that same antenna being struck by lightning, and it shows the aftermath of the lightning strike. And all the current did not go down through the coax. It left at the mounting points. So I'm not too worried about it, even if the radio was connected by accident. I mean, I would always disconnect it, but I'm not too worried about that lightning getting into the house. It would go pretty much straight to ground. Still, I mean, if it's already higher than all the houses, it's higher than the houses by about maybe 2 or 3 feet whenever it's down, and it's higher than the houses by like 20 feet when it's up. So I'm just trying to decide whether or not, because it's actually kind of a lot of work. I have a lot of equipment on there. I have a lot of guy wires and the inverted V. It's just a big mess when you try and lower it. And I'm wondering, should I just leave it up? I think I may just start leaving it up, especially once I get my proper polyphasers in and everything. And I need to go tomorrow. Tomorrow, my project is going to be going to Lowe's and trying to find a ground rod and then grounding the base of the push-up pole. Because right now it's just kind of sitting in the dirt, but I need a proper rod in there.
Yeah, you'll find them. They're not expensive. They're where the electrical stuff is. They're actually normally where the gray electrical conduit is.
Right.
And you'll see a bunch of them there. You can get up to 25 feet long, but an 8-foot one is fine. And then really hammer it all the way into the ground. There's all sorts of things. If you look on YouTube, there's all sorts of guides to do it. You can put electric drill on the top of it and spin it a little bit. What I do is pour water down the side of it, you know, when I'm hammering it in.
Of course, as much rain as we've had around here lately, it's probably wet enough.
Yeah, you're probably wet enough. You can probably get it in, but make the effort. You know, the first couple of feet are easy, and then the next couple of feet are tough, and then after that, it's really tough.
My initial tower, the one with the beam on it, same push-up pole. I put an 8-foot galvanized rod in the ground using nothing but I believe I was using a normal hammer.
Oh wow!
Okay. It might have been like a slightly larger than normal hammer,
It takes
but
a while. But I put them in with hammers too.
Yeah, I put them in with a sledgehammer, but a small one. You're like a 5-pound hammer.
Yeah. So which is the other question I have is which is preferred, copper or galvanized?
I like copper better.
Yeah, you can get copper covered steel rods.
That's
the grounding rods that the utility company use. That's the ones that Lowe's will sell in the electrical department.
Lowe's and Home Depot have that.
Yeah, Home Depot. They're copper covered, you know, steel rod. Because if you put a piece of copper in like that,
it's like this here. Maybe it says Galvan terminal copper rods.
Yeah.
That looks a bit smart. The ones I use are a bit rough.
Well, that's a picture. It's probably
go scroll down a little bit. On the right hand side, scroll down, or up, whatever. Go up, go back to where the rod was. Go one more up. That on the right hand side there, the Eaton item.
Mm-hmm.
That's what I use for grounding my shack.
Yeah.
In the shack, that's screwed through this hole here. It's screwed onto the plywood that I rest my regs on, and then out of those go just this piece of copper wire that I showed you. Regular ground goes out of that to all the equipment. Yeah. And that made a lot of difference. That made a lot of difference to noise, the RF noise. But I told you once before, when I'm serious and I get on the bands, I switch off things like, anything.
Yeah.
Because,
Yeah.
like toothbrushes.
Maybe you run a line from each thing to that terminal.
Oh yeah. You
Yeah.
don't daisy chain
No, no.
each one of those. So you can put 4 and 6. You can put 10 pieces of equipment on that. No more. If you want another one, you put another one by the side of it if you got more. But I don't know about the galvanized. Does it say it's? Yeah,
I've used rebar. Rebar that you put in concrete.
Yeah, rebar's okay, but I prefer the copper covered. I think it might be copper covered rebar.
Well, these are the only two choices they have.
It's terminal copper rods.
Is the
Yeah,
copper.
yeah. I mean, for the $3, $5.
I'd go with the
No, what was it? 14 to 17. I would go with the more expensive. Just
I'd go with-
Yeah.
copper's a way better conductor than whatever. Yeah, that looks like it. Yeah, it's a good picture
That's
because
what you got. I got 4 of those sitting out in the garage.
yeah,
Is that 8 foot?
That's 8.
Yeah.
Those should be 8 feet.
I mean, 8's the
there should be a minimum of 8
obviously,
foot.
right?
You can put 20. 8 foot long. 0.625 of an inch thick, 8 foot long. And that's a grounding rod. That's the thing you need. And then that thing that I showed you that I've got will do the.
Yeah. Well, I could probably find one of those in our warehouse. We have a lot of that kind of stuff already because we're an electrical company. So okay, I'll pick one of those up tomorrow. Then I might get 2 actually. One for the base of the tower, then one for the.
If you're an electrical
box.
company, you should have those in stock.
Yeah.
Well, we do, but we need those for actual jobs.
Well, for customers. Yeah.
Yeah.
And the other thing I'd do is make sure if you know where your utility ground is, you want to tie into that too.
And every 15 feet, no more than 15 feet. So if your utility ground is 30 feet away from where you're putting your rod in, put another one in between.
Yeah. And make sure they're tied together.
Yeah, 15 feet is the recommended code, I believe.
Okay.
And boy, this brings back memories of when we used to do this with the fire stations in the EOC years ago. We used to have to CAD weld everything.
Yeah.
Because when you CAD weld, it's like it's almost like
Thanks.
Yeah, but that's kind of industrial. We're a step down from that. And the other thing is that the fire station stuff, you're looking at a different thing. What we're looking at is to get a good ground for RF, not a good ground for safety, although safety helps. And we're also looking to reduce, as much noise as we possibly can. But that's another issue. But you will notice that if you ground everything, your signal to noise ratio of the radio will get better. But to be honest, the amount of noise and crap that you generate yourself is, as I say, if you've got chargers that are running all your handy talkies, if you've got chargers that are charging the batteries that go into
wall warts you have, the more
wall
wall
warts,
warts.
yeah,
we
They
call
go-
at work we call them wall moles, but yeah, same thing.
that's right. Throw them all away. Get rid of them.
Well,
Or
that's-
only plug them in. I've got a separate little box just around the back of the shack here that all my handy talkies and all my chargers and wall warts where I use, but I don't use wall warts very much, they're all on there. And when I switch my bench off or my desk where all my equipment is, I switch on those. So I charge all my radios, handy talkies or any, my Fox Hunt transmitter and all that stuff. They get charged overnight when the radios aren't working,
right.
because they all generate noise. And noise is, the thing is with noise, it's not accumulative as far as amplitude's concerned. It's accumulative as far as density is concerned. And so if you've got a little tiny signal in the noise and you've only got a little bit of noise, doesn't matter what the amplitude is, you can still work them. But if you've got a lot of noise, very little amplitude of that noise, but it's very dense, nothing's going to get through it.
Yeah.
So unplug those toothbrushes, the hair, the beard trimmers, the electric shavers,
And
you
you'd
know.
be surprised how many of those things you probably have plugged in your house.
Exactly. Yeah,
I've
you know,
probably got 10 of them just in the shack out here that I'm still
yeah,
using.
emergency lights that you charge. You know, you
It's
plug them
great.
in the wall, leave them there.
Whenever I get
My goal is to get everything I have that's direct current on my 12-volt power supply, and then I can step it down to whatever. And that way I just have one power supply running, and it'll also have batteries eventually that will be with it, so that all my 12-volt stuff will be run separate, and then I can just charge the batteries and have a power supply or whatever. But my goal is to have no wall warts eventually, because I know those are horrible. And truthfully, they're not good on electricity. If you've got 20 of those plugged in, I guarantee 5 of them you don't even need plugged in.
Yeah, and they get
every
warm.
one of those burn your electricity 24 hours a day.
That's right.
It's
Yeah.
not a lot, but if you've got 20 of them,
light bill.
it's $10 a month, $5 a month, $3 a month. It's still your money. Anyway,
And don't forget, with your power supply, the negative on your power supply is not ground. It's negative to the positive. It's
Right.
not ground.
right,
And I mean, I
exactly.
think we did that one night here, didn't we, with you, Joseph?
Yes.
yeah.
When we measured the negative, we measured from positive to negative, and it read 12 volts. We read positive to the chassis, and it read 0.
Yep.
So you want to ground that chassis as well.
Right. All right, so I want to move on because I want to get Dave's FT8 system up. So I just want to tell you guys one last thing on this. When I was a firefighter years ago, we had a firefighter that, now I want you to get this. This was great. This was in 1988. Okay, this was a long time ago. The firefighter that was on duty by himself was talking on the telephone, leaning on the base radio while he was adjusting the cable box, and the station got hit by lightning. And we think that what actually put him on his ass and knocked him unconscious was it came through the radio, the antenna, and that Midland base radio was smoked, physically smoked. I'm surprised it didn't burn.
Wow.
It was physically smoked. That was the first time I ever saw a car radio on a little pedestal, was what we got to replace it. And now that's your standard base radio now. It's nothing but a mobile on a little pedestal. So I thought that was pretty cool. But anyway, he was actually had to go and get checked out. He was hurt pretty bad. We actually ran code to the station because we knew the guy at the station had been hurt by lightning.